Centripetal acceleration. Welcome. You whirl a 5 kg body attached to a 3 meter massless cord around your head in a horizontal circle with a constant tangential speed of 2 meters per second. So the object is going around the circle at 2 meters per second, constant speed of 2 meters per second. Why is the acceleration not zero? Number one, why is the acceleration not zero? Number two, does the acceleration vector have a centripetal component? Number three, does the acceleration vector have a tangential component? Number four, does the acceleration vector have centripetal and tangential components? Number five, what causes the net force? Number six, what is the magnitude of the acceleration? And number seven, what is the net force towards the center in newtons? So when you whirl an object around your circle at 2 meters per second, why is the acceleration not zero? Why is the acceleration not zero? Acceleration is the rate of change of velocity. What is acceleration? Acceleration is change of velocity divided by time, rate of change of velocity. Acceleration is the rate of change of velocity. Velocity is a vector. Velocity is a vector. A velocity has magnitude and direction. A vector has magnitude and direction. Velocity is a vector. So the velocity vector has a magnitude and direction. A vector has magnitude and direction. So how do we get a change for the vector? How about we change the direction? How about we change the magnitude? How about we change magnitude and direction? So in all three cases, we do have change because velocity vector has magnitude and direction. So if you change either direction or magnitude or both, then you have change of the vector. Why is that there is change of direction? When an object is moving in a circle, do not forget our circle is horizontal circle. But when an object is moving in a circle, the direction is constantly changing. So the direction is constantly changing. So even when an object is moving at constant speed, the direction is constantly changing. And because of that, there is always an acceleration. So a vector has magnitude and direction. A vector has magnitude and direction. Change of direction alone can make the vector change. Change of magnitude alone can make the vector change. Change of direction and magnitude can also make the vector change. For an object moving in a circular path, direction is constantly changing. So even if speed is a constant, the direction is not. It is constantly changing. This causes centripetal acceleration. Number two, does the acceleration vector have a centripetal component? Yes, and it is towards the center. The centripetal acceleration towards the center is v squared over r. What is v? Tangential speed in meters per second. What is r? Radius of the circle in meters. What is the unit of acceleration? Meter per second per second. Number three, does the acceleration vector have a tangential component? In our case, there is no change. There is no change of the magnitude of the tangential speed. Because the magnitude is not changing, there is no tangential acceleration. So we have zero tangential acceleration. Zero tangential acceleration. Does the acceleration vector have centripetal and tangential components? We do have centripetal acceleration. We have no tangential acceleration. There is centripetal acceleration. There is always an acceleration towards the center when an object is moving in a circle. When an object is moving in a horizontal circle, there is no tangential acceleration if there is no change of the tangential speed. So no to tangential acceleration, yes to centripetal acceleration, yes and no. What causes the net force? Well, remember, we have, here is our mass, and here is the center, and tension is a pulling force. It pulls away from the object. So here is the direction of the tension. So when you draw the free body diagram, what is the only force acting towards the center? It is tension. So tension is the only force acting towards the center, and it is that which causes the net force. So T is the only force acting towards the center. So what is the net force acting towards the center? mv squared over r. What is m? Mass in kg. What is v? Speed in meters per second. What is r? Radius in meters. Number 6, what is the magnitude of the acceleration? So magnitude of the acceleration is given by square root of AC squared plus AT squared. What is AC? Centripetal acceleration. What is AT? Tangential acceleration. But we know that the tangential acceleration is 0, so we don't have to worry about that. How about the centripetal acceleration? Centripetal acceleration is square of the speed divided by radius. Square of the speed divided by radius. V is given as 2 meters per second. Radius is given as 3 meters. Radius is given as 3 meters. So when you substitute that, we get centripetal acceleration is 1.33. So we get centripetal acceleration as 1.33 meters per second per second. So what is our acceleration? 1.33 meters per second per second. What is the net force towards the center? Once you have the acceleration as v squared over r, the acceleration towards the center as v squared over r, what is the net force towards the center? Net force towards the center is mv squared over r. So mv squared over r. So substitute for m equal to 5 kg, and then substitute for v equal to 2, and then substitute for r is equal to 3. So when you do that, we get 6.67 newtons. 6.67 newtons. So net force towards the center is 6.67 newtons. So what is the tension? 6.67 newtons. 6.67 newtons. So our string should be able to withstand a force of 6.67 newtons. And this is George Mathew signing off. Good luck.